Hello students, welcome back to the math class. In our last class, we discussed the first exercise of the chapter triangle. Today, we are going to learn some more properties of triangle. So, let's go ahead. So, properties of triangles, that means how they look, what are their characteristics, how they are being differentiated, all these come under properties of triangle. So, first of all, we are going to discuss about the isosceles triangle. Okay? So, students, let us do an activity as given in your book. Construct a triangle in which two sides are equal, say each equal to 3.5 centimeter and the third side equal to 5 centimeter. You have done such construction in earlier classes. Do you remember what is such a triangle called? A triangle in which two sides are equal is called an isosceles triangle. So, triangle ABC as given in your book is an isosceles triangle with sides AB is equal to AC. So, when we measure angle B and angle C, we can observe that their value is also equal to each other. We can repeat this activity with other isosceles triangles as well, and we will come to a conclusion that the angles which are opposite to the equal sides of an isosceles triangle are also equal to each other. Okay? This is a very important result and is indeed true for any isosceles triangle. So, let us prove it. Okay? So, this gives us the theorem 7.2 that angles opposite to equal sides of an isosceles triangle are equal. This result can be proved in many ways. One of the proofs is how we are going to do it, and that is also given in your book. So, let us do it. Okay? Students, I have constructed a triangle ABC as given in your book, and as per the data given, AB is equal to AC, AB is equal to AC. Fine. So, this is an isosceles triangle where two sides AB and AC are equal to each other, and what we need to prove? To prove angle B is equal to angle C. That means angle B, this one, and angle C, this one. So, angle B is the angle facing the side AC and angle C is the angle facing the side AB, or you can say it is opposite to the side AB and angle B is the opposite to the side AC. Fine. So, as you can see in the figure, AD is the bisector of angle A. We need to construct it, okay, to prove. Let us prove it. Prove. Fine. So, let us construct a bisector of angle A, that is intersecting BC at point D. So, AD is the bisector of angle A. What does it mean? It means angle BAD is equal to angle CAD. Fine. Now, let us concentrate on triangles ABD and ACD. In triangle ABD and triangle ACD. Students, why am I doing so? See, we need to prove angle B is equal to angle C. So, we have known about congruency, and we know that when two triangles are congruent, then the corresponding sides and angles are equal to each other. So, if we can prove that triangle ABD and triangle ACD are congruent to each other, then automatically we can go for the similarity, or the value of angle ABD will be equal to angle ACD, that means angle B is equal to angle C. So, now we are going to prove that these two triangles are congruent. So, what we find? AB is equal to AC, that is given, Fine. Then angle BAD is equal to angle CAD by construction. And AD is the common side. AD common side. So in these two triangles we have two sides and included angle equal to each other. That's why triangle ABD is congruent to triangle ACD. Fine. Triangle ABD is congruent to triangle ACD by which rule of congruency? Side angle and side congruency. Fine. So, as these two triangles are congruent to each other, I can say that angle ABD is equal to angle ACD, CPCT. Fine. So, we have proved that angle ABD is equal to angle ACD, that means angle B is equal to angle C. Proved. Fine. So, what we come to know that in case of an isosceles triangle, the angles opposite to the equal sides are also equal to each other. Okay. So, what theorem 7.2 says? Angles opposite to equal sides of an isosceles triangles are equal. Now, we have proved it by the triangle ABC. Okay. Hope you have understood. So, students, is the converse of this theorem is true? That is, if two angles of any triangle are equal, can we conclude that the sides opposite to them are also equal? Let us do an activity and try to prove this. Okay? Students, as given in your book, I have constructed a triangle ABC over here, in which as per the given data, angle B is equal to angle C. Angle B is equal to angle C, that is 50 degree. Okay. So, this is also an isosceles triangle. We need to prove that the sides opposite to the equal angles of the triangle are equal to each other. That means we need to prove AB is equal to AC. Fine. So, in the same way, if we can prove that triangle ABD and triangle ACD are congruent to each other, then we come to a conclusion that AB is equal to AC, because they will be corresponding sides of the congruent triangles. Okay. So, let us try to prove that triangle ABD and triangle ACD are congruent triangle. Fine. For that, let us construct the bisector of angle A, that is AD, which is intersecting side BC at D. Fine. So, construction AD bisector of angle A. Fine. So, in triangle ABD and triangle ACD, angle ABD is equal to angle ACD, that is given. Angle BAD is equal to angle CAD, this is by construction. And AD is your common side. Fine. So, we have two angles equal to each other and there is a common side. That means triangle ABD is congruent to triangle ACD by which rule of congruency? Hope you can get it. Exactly, it is by AAS. By AAS. So, as these two triangles are congruent to each other, now I can write that AB is equal to AC, CPCT. So it is proved that the opposite sides of the equal angles of any isosceles triangle are also equal to each other. So we have come to the conclusion that the converse of the theorem holds true. Okay, hope you have understood. So students, this brings us to the conclusion for another theorem, that is theorem 7.3, which says the sides opposite to equal angles of a triangle are equal. This is the converse of theorem 7.2. We can prove this theorem by ASA congruence rule, okay, as well as AAS congruence rule. So students, let us go through the activity. Okay, construct a triangle ABC with BC of any length and angle B is equal to angle C is equal to 50 degree. Fine. Draw the bisector of angle A and let it intersect BC at D as it is given in your book in figure 7.26. Cut out the triangle from the sheet of paper and fold it along AD so that vertex C falls on vertex B. What can you say about sides AC and AB? Observe that AC covers AB completely. So AC is equal to AB. Repeat this activity with some more triangles. Each time you will observe that the sides opposite to equal angles are equal. So we have the following, that is, we have come to the conclusion for theorem 7.3. So students, now we have proved that the sides opposite to equal angles of a triangle are equal by AAS congruency. Okay. Now let us take some examples to apply these results. Fine. Students, let us discuss example 4. Okay. What it says? It says in triangle ABC, the bisector AD of angle A is perpendicular to side BC. Show that AB is equal to AC and triangle ABC is isosceles. So let me draw the diagram as it is given in your book. Okay. So students, you can clearly see that triangle ABC is there and AD is the bisector of angle A. Okay. The bisector of angle A, that means AD is perpendicular to side BC. So let us try to solve and find out about AB and AC. Fine. So as AD is perpendicular to BC, after construction we have two triangles ABD and ACD. So in triangle ABD and triangle ACD, AD is common. Okay, AD is your common, and it is given that angle BAD is equal to angle CAD. Angle BAD is equal to angle CAD. It is also given. Why? Because AD is the bisector of angle A. Fine. What else? Angle ADB is equal to angle ADC, that is 90 degree, isn't it? As AD is perpendicular to BC. Fine. So what we have found that these two triangles, triangle ABD and triangle ACD, they are congruent, isn't it? They are congruent because they have two angles equal to each other and they have a common arm. Both the angles, they have a common arm. In this case, triangle ABD is congruent to triangle ACD by angle side angle congruency. Angle side angle. So they have both the angles, they have a common arm. They have a common arm. So AD is the arm of angle BAD as well as angle ADB. So they are following ASA congruency. As triangle ABD is congruent to triangle ACD, now I can write AB is equal to AC because CPCT. Corresponding part of congruent triangles. That means triangle ABC is an isosceles triangle. Fine. So, triangle ABC is isosceles. We have proved it. Hope you have understood it. So, students, let us discuss example 5. What it says? E and F are respectively the midpoints of equal sides AB and AC of triangle ABC. Show that BF is equal to CE. Okay, let us do it. Students, I have constructed the figure as it is given in your book. So, as per the given data, ABC is a triangle in which AB is equal to AC and EF are the midpoints of sides AB and AC respectively. So, let us go for the solution. Fine. So, in triangle ABF and triangle ACE, what is it given? AB is equal to AC. So, triangle ABF and triangle ACE. ABF and triangle ACE. It is given that AB is equal to AC. It is given. Fine. And if AB is equal to AC, what else is there? In these two triangles, angle A is a common angle. Angle A is common. Fine. So, in these two triangles, triangle ABF and ACE, AB is equal to AC and angle A is common. So, now we have two datas. Okay. What else we can find from these two triangles? That AE is equal to AF. AE is equal to AF because they are half of the sides AB and AC. Fine. So, now we have AE and AF. Okay, AE and AF equal to each other, AB and AC equal to each other, and A is a common angle. Now we have two sides and the included angle. So triangle ABF is congruent to triangle ACE by side angle side congruency. So students, as we have proved, triangle ABF and triangle ACE are congruent to each other. Now we can write that BF is equal to EC. BF is equal to EC. Now we have proved that BF is equal to EC by CPCT. Fine. So this concludes our example 5. Let us discuss example 6. Okay. What it says? It says in an isosceles triangle ABC with AB is equal to AC, D and E are points on BC such that BE is equal to CD. Show that AD is equal to AE. So let us go for the solution. Before that, let me construct the diagram. Okay. Students, I have constructed the diagram as it is given in your book. So, ABC is a triangle with AB is equal to AC, D and E are points on BC such that BE is equal to CD, and we need to prove that AD is equal to A. So, let us go for the solution. Fine. So, let us concentrate on triangle ABD and triangle ACE. In triangle ABD and triangle ACE, okay, we have AB is equal to AC, it is given, fine, and angle B is equal to angle C is equal to angle C. Why? Because it is an isosceles triangle. Then BE is equal to CD, BE is equal to CD, it is also given. If BE is equal to CD and BC is the base, so in this side we can say that as BE is equal to CD, that means BE minus DE is equal to CD minus CE. Why? DE is your common to both BE and CD. Okay. So, what is BE minus DE? It is BD. So, BD is equal to CE. BD is equal to CE. Okay. So, if BD is equal to CE and we concentrate on triangle ABD and triangle ACE, now what we have found that AB is equal to AC, angle B is equal to angle C and BD is equal to CE. That means we have two sides and included angle, side AB and BD and included angle B. In case of triangle ACE, side AC and C and included angle C, they are equal to each other. Then we can write triangle ABD is congruent to triangle ACE by side angle side congruency. Okay. So, as these two triangles are congruent, so I can say that AD is equal to AE. So, AD is equal to AE, CP, CT. Fine. So, in this way we have proved that AD is equal to AE. Hope you have understood this. Okay. Now, let us go to exercise 7.2. Let us see what it says in question number 1. It says, in an isosceles triangle ABC with AB is equal to AC, the bisectors of angle B and angle C intersect each other at O. Join A to O and show that OB is equal to OC and AO bisects angle A. So, let me draw the diagram and then we will discuss the question. Okay. So, students, first of all, let us concentrate on this figure. I have constructed this figure as per the given data, which says ABC is a triangle in which AB is equal to AC. That means AB is equal to AC. So, clearly ABC is an isosceles triangle. The bisector of angle B and angle C intersect each other at O. Bisector of angle B, that is BO, bisector of angle C, that is CO. Okay. And instruction is there to join A to O, join A to O. That means we have now three triangles, those are in the internal of triangle ABC, isn't it? Those are AOB, BOC and AOC. Fine. So, what are the given data? AB is equal to AC, angle B and angle C, they are bisected by BO and CO respectively. Fine. Now, to prove, what we need to prove? First, OB is equal to OC. OB is equal to OC, and second, AO bisects angle A. Okay, let us prove. We need to prove that OB is equal to OC. Let us first of all concentrate where these two sides lie. OB and OC, they are parts of triangles AOB and AOC respectively. So, if we can prove that triangle AOB is congruent to triangle AOC, then we can have the conclusion that OB is equal to OC as their corresponding sides. So, let us concentrate in triangle AOB and AOC. In triangle AOB and triangle AOC, AB is equal to AC, it is given. Fine. Angle ABO is equal to angle ACO. Why? Because B is equal to C, angle B is equal to angle C. Those are the opposite angles of equal sides AB and AC, and BO and CO, they are bisectors of those angles. That means as angle B is equal to angle C, so half of B should be equal to half of angle C. So ABO is equal to angle ACO. That means half of angle B is equal to half of angle C. Fine. AO is your common side. AO is your common. So students, now we have AB is equal to AC, angle ABO is equal to angle ACO, and AO is common side. So someone might be thinking that now these two triangles are congruent as we have two sides equal to each other and one of the angles is equal to each other. But whether this angle is the included angle of these two sides, then only we can go for SAS congruency. We do not have anything called SSA congruency. So let us first check whether angle ABO is included angle of triangle ABO. AB and AO has the included angle BAO, not ABO, isn't it? BAO is the included angle of side AB and AO. So, though angle ABO is equal to angle ACO, but these two angles are not the included angles of the respective triangles. That's why we cannot go for the congruency. But from here, we found that as half of B is equal to half of C, let us concentrate on triangle BOC. Okay? Triangle BOC. In triangle BOC, okay, half of angle B is equal to half of angle C, that is angle OBC is equal to angle OCB. So, as these two angles are equal to each other, so in triangle OBC, we have found that OB is equal to OC, as we know that the sides opposite to the equal angles of a triangle are also equal. That means OBC is a isosceles triangle. OBC is an isosceles triangle. So, of equal angles. Now we can use this data to prove the congruency between triangle AOB and AOC. Let us do that. So, in triangle AOB and triangle AOC, now we have AO common side, okay, OB is equal to OC, let it proved, fine. See, AO is the common side, OB is equal to OC and AB is equal to AC. AC, this is given. So hence triangle AOB is congruent to triangle AOC by SSS congruency. Fine. So we have proved that OB is equal to OC. Now as ABO and ACO are congruent, hence angle BAO is equal to angle CAO, CPCT. As angle BAO is equal to angle CAO, now it is proved that AO is the bisector of angle A. Why? Because angle BAO is equal to angle CAO. So in this way we have proved both the bits, that is OB is equal to OC and AO bisects angle A. Hope you understood. So students, in our next class we will discuss some more concepts about the triangles. Okay? Till then you practice all the questions again, revise the concepts. Okay? Till then keep smiling, take care, thank you.